Let's talk about adding and subtracting rational expressions. So we're going to use just the same old rules you use when adding and subtracting fractions, but we're going to use them in the context of rational expressions. Remember that a rational expression is just a quotient of two polynomials. So remember, quotient meaning the thing you get when you divide two things, right? So it's the kind of the result of that. And polynomials, so it's the quotient of two polynomials. Polynomials just being an expression that may have one term or many terms, may or may not be involving variables. So it could be anything from just simply x cubed to x squared plus x plus abc plus 10. Okay, it could be anything like that. So we're just taking two of them, dividing them, and our result is a rational expression. Now remember, when we're adding or subtracting fractions, the denominators must be equal. So I can't just add 1/2 and 1/3 together without first getting like denominators. However, if I do have the same denominators, right, if I just had 3/8 minus 1/8, I would do this by subtracting the numerators, so 3 minus 1 is 2, and keeping the denominator, right? The denominator is kind of just identifying the units I'm using. So 3/8 minus 1/8 is 2/8, or 1/4. So again, to add or subtract fractions, the denominators must be equal, and when we actually carry out the addition or subtraction, we're combining the numerator and then leaving the denominator as is. So, in the context of rational expressions, it's going to work the same exact way. So, here's an expression where we're asked to add these two fractions. Notice that our denominators are the same. So that means, cool, we're good to go, green light, let's add them together. So, 3x minus 4 plus 2x plus 5 becomes our new numerator, and our denominator stays x plus 3. Let's consider our numerator. We want to simplify it. So, 3x plus 2x is 5x, and negative 4 plus 5 is just positive 1. And our numerator, again, it's just x plus 3. Now notice, so now we've done our addition, and we've simplified. Notice that we're also asked to identify any x values for which the expression is undefined, meaning what causes the denominator to equal 0? What value of x causes this? So you would take your denominator, in this case it's a simple denominator, set it equal to 0, and solve for x. Whatever you get, that's the value for which x would cause the expression to be undefined. So our final answer would be this fraction, 5x plus 1 over x plus 3, where x cannot equal negative 3, because if x equals negative 3, our function or our expression is undefined. Let's practice again. So once again, this time we're subtracting. Notice that our denominators, that's the first thing you want to check. We have the same denominator here, so we can carry on with the subtraction. So we're going to take 15x plus 2, and we're going to subtract 2x minus 1. Notice that I had to keep this term, or this numerator, in parentheses, right? Because I want to make sure that I'm not just applying this subtraction to the 2x, I need to also distribute it to the negative 1. My denominator stays the same, 7x plus 1. Let's simplify the numerator. So I have 15x minus 2x. 15x minus 2x is 13x. Okay, what about my other term? I have positive 2 minus negative 1. Positive 2 minus negative 1. Positive 2 minus negative 1. Well, that's the same thing as 2 plus 1, which is 3. All over 7x plus 1. So there is my expression, and I still need to identify the value of x, which causes the expression to be undefined. Remember, that means I take the denominator, I'm going to set this term, 7x plus 1, equal to 0, and solve for x. X equals negative 1/7. So my final answer is this term, or this expression, 13x plus 3 over 7x plus 1, where x cannot be equal to negative 1 over 7 because it would cause the expression to be undefined. Let's keep practicing. So up until now, those two example problems both had denominators that were already perfect and matching for us. What happens when you have unlike denominators? So going back to my example of 1/2 maybe times or minus 1/3. I can't solve this yet, right? I have to have the same denominator. So what can I do? One technique is just to multiply. I need a common denominator here. So I'm going to multiply this times 3/3, and it becomes 3/6. Notice I multiplied 3 by both the numerator and the denominator. And I'll do the same thing with the other term. So I multiplied the 2 times 3. Now I'm going to multiply the 3 times 2/2. 1 times 2 is 2. 3 times 2 is 6. Now I have matching denominators. 6 was my lowest common denominator, and I can subtract. 3 minus 2 is 1, so my answer is 1/6. Again, I accomplished this by multiplying, so taking this denominator and applying it to the other term, and then taking the 3, multiplying that by the whole term on the left. There's another way to do this. For example, if I was trying to calculate maybe 1/2 minus 1/8. I could do the same thing I did before. I could say, okay, I'll just take the 2 and multiply the other term by 2 in the numerator and denominator, and end up with 2/16. And then I could take 8 and do the same thing, so that 8 gets multiplied, and I get 8/16. And look at that, both of my denominators are 16. I'm good to go. But there's another way I could do this. I could also say, you know what? Rather, I'll just leave 8 alone, because I know that I could make this 2 into an 8 by multiplying it by 4. I knew that 2 times 4 is equal to 8. So I'm going to multiply this numerator and denominator by 4, which gives me 4/8 minus 1/8. And look at that. I end up with the same answer. So in this case, again, I chose to multiply the denominators, the terms by the denominators, right? In this case, I only had to do one operation. It was much faster. I said, hey, I know that 2, when multiplied by 4, I knew that 8 has a factor of 2 in it, and I can turn that 2 into an 8 by multiplying it by 4. So I multiplied the numerator and the denominator by 4 to get that. So hopefully you remember doing that in math classes past, because we're going to use the same technique for dealing with rational expressions. We're going to find the lowest common multiple, just as in the case of 2 and 8, the lowest common multiple is 8, by factoring. So again, if you have not reviewed factoring recently, if you're not totally confident about factoring polynomials, go watch my video on this subject, because I'm not going to cover it in depth here. So to find the lowest common multiple of polynomials, I'm going to factor them. I'm going to list the different factors, and I'm going to use the highest powers of each common factor. It'll make more sense once we have it in play here. So let's look at this addition problem. Notice that I have this quadratic expression over here. I'm going to factor it to figure out what its terms are, just as if I had perhaps two denominators. If I had 10 and if I had 5, I would factor 10 into 5 times 2, and I'd say, hey, here's a factor of 5, here's a factor of 5. If I multiply this guy times 2, they'll match, because that's the only difference. I'm going to use the same technique here. So let's factor that quadratic expression. So that becomes, I always set up my framework first, so I'm considering 20, and I'm asking myself what two numbers, when multiplied together, equal positive 20, and when added together, equal negative 9. So if I take negative 5 and negative 4, and multiply them together, I get positive 20. I add them together, I get negative 9. I leave my numerator alone. This other numerator is fine. This denominator is already factored. So what do you notice? Well, you would say, hey, they have a common factor of x minus 4. The only difference is that this denominator also has x minus 5 as a term. So I can simplify, or I can rectify this in this expression by taking x minus 5 over x minus 5 and multiplying it. So I'm going to multiply both the numerator and the denominator by x minus 5. Continuing, that gives me 5x minus 25 over, and I'll just leave this denominator factored, x minus 4 times x minus 5. So now, I'm ready to combine. I'm ready to add these together. So I end up with, let's find some room, I'm taking this numerator and adding it to this numerator. X plus 5x is 6x. 3 minus 25 is negative 22 over, and I'll leave my denominator as is, x minus 4 over x minus 5. X minus 4, x minus 5. So, this is my simplified expression, 6x minus 22 over x minus 4 times x minus 5. Now, don't forget you also have to identify the x values for which the expression is undefined. In this case, remember, you take each term in the denominator, x minus 4 and x minus 5, set them both equal to 0, and then solve for x. So in this case, by solving for x, we find the values for which the expression is undefined. So I would say x is undefined at 4 and at 5. So my total answer would be both the simplified fraction and the values for which it's undefined. Let's practice again. I think this is the last practice we have here. So we're going to add these two terms together, and we're going to accomplish it by first finding a common denominator, and we do that by factoring. So I'm going to factor this guy. So I set up my framework. 42. So what times what equals negative 42? And using those same two numbers equals negative. Notice that this is negative 1. What about 6 and 7? So if I had a positive 6 and a negative 7, and I multiplied them together, I would get negative 42, and I added them together, I'd get negative 1. Notice that my other denominator already has that factor of x plus 6. So if I multiply the denominator times x minus 7 and the numerator times x minus 7, I'll have common denominators. So I end up with negative 3x squared plus 21x all over x plus 6 times x minus 7. And I'm adding that to this term. All right. So I add my numerators together, so 3x plus negative 3x squared plus 21x all over x minus 7, x plus 6. I simplify my numerator. Negative 3x squared, and then I will take 3x and I'll add it to 21x, so that's 24x, over x minus 7, x minus 6. My undefined values I will find by taking each term of the denominator and setting it equal to 0 and solving for x. Okay, so my values are undefined when x equals negative 7 or equals 7 or negative 6. So in my answer, I not only write my simplified expression, but I say x cannot equal 7 and x cannot equal negative 6 because those values would cause the expression to be undefined. So that's it for addition and subtraction. Remember, it works just the same as it does with fractions. You have to have a common denominator in order to add or subtract. We find the common denominator by finding factors of the denominators we have. So in this case, I factored. Figure out what you need to do to make the denominators match, whether it's taking a term and multiplying the other expression by that term in the numerator and denominator, or whatever you need to do. Once you have matching denominators, you can carry out the addition or subtraction. In the case of subtraction, make sure if you have make sure that you are distributing the negative sign to all of the terms that you're subtracting. So for example, you wouldn't just write minus d minus f plus g. You would have to distribute that negative. So you'd end up with a negative d, a positive f, and a negative g. Thanks for tuning in, guys. Let me know if you have any questions.